Hi friends, welcome to my weekly live stream about the Uno platform. I'm spending about an hour every week, uh, taking a look at what the Uno platform has been doing, and taking a look at a few specific things that I've been working on. Like today is going to be threading and a bit of NuGet packaging things. So um, that's going to be what is going to be the today's topics. I just want to spend a bit of time going back to one of the issues that we had last week, and it was something that was actually quite interesting. And I'm going to be opening one of the last week's issues. I think it was that one, if I remember correctly. And it was an issue about bindings and X binds, and it was about making sure that we're getting to the right bindings at the right time. And I thought I had that one there, but maybe not. So let's see. Let's go find that specific issue. Hi, Jose. Please, if possible, could you show us some latest news about the Uno platform for starting your next session? Will be helpful for everyone. Most of the things that I've been doing, are on the Uno platform from last week. So if you take a look at that one, you're gonna get some new things. There hasn't been that much news lately. Otherwise, I'm gonna talk about them in a few minutes. So, which are WebAssembly related. But if you want all those news, you can go to the blog, and most of the content is already there. So especially the Uno platform 4.3 update. So quickly, let me go back to GitHub, and it was actually an interesting one. It was a new kind of a new behavior that we didn't know about, and it was, I think, a search for converter. I think we had the issue there. It's a closed one because it was fixed. Converters, triggers, convert back. And so that one is actually quite interesting. But there's another one. Oh, yeah, it's that one specifically. So let's take that specific repro, and we're going to take a look at what that does, and we're going to try to understand the original. Oh, actually, it was there already. Haha, there it is. Okay, so let's open that one specifically. And it's something that we're probably going to be documenting specifically because it's a behavior that people generally try to code by hand, and it is actually easier to get right using that new pattern that is coming from xbind. So let's take a look. Actually, that one was already modified, so we're going to be going to take the original one. So we have the original issue. Okay, so let's go and open it again. Converter incorrect. Jose is asking, what's the difference between Linux GTK and Linux frame buffer? So the difference between the two are about how Uno interacts with the rest of the system. So for instance, if you're running using, let's say, Linux GTK, you generally want your app to run inside of a window manager, whether it's Wayland or X11, and then running inside of a let's say a GNOME or KDE or something like that, depending on which one you want to run in. But the thing is that Uno has to interact with the rest of the system. So for instance, knowing the size of the window, or knowing when you click somewhere on the screen, or that you minimize the window, or whatever, you type using the keyboard and others. So we're instead of relying on directly X11 or Wayland or others to understand how the system works, we just use GTK to channel those events like if it were a normal application. So it makes it easier for us to work with. Now, if you're on an embedded device, Raspberry Pi or similar, you may not have a window manager to work with. So in that context, it's easier to work with the frame buffer. So Linux provide that. It's basically raw access to the device, the display device, where you can basically write pixels one by one. And what we're doing is using Skia to render that. And there's also a way to use, I don't remember the name, but I think it's libinput, if I remember correctly, to do the interactions with, we're basically hijacking the keyboard and mouse so that you can have the interaction with the rest of the system. So, but basically your application is just that one application running at that time when you're using the frame buffer. It's a very specific case, but many people do want to have that scenario covered. So for the converter, let's take a look at the UWP application, because the rest is not particularly interesting in that case. And what we have here is a text box with a binding, an X bind specifically to enter the amount. So enter the amount is inside of a view model here. And you can see that it's a decimal, and it's basically set specifically using a binding. So it notifies when the property is changed, and everything works properly. Now it's a two-way binding, and it's also having a converter. So that converter, let's launch the application so you can see what it does. So let's do x64 so it shows quickly. And so we're going to take a look at that in the meantime at the converter. So basically the converter says from the value that's coming from my view model, take that decimal and add the currency symbol in front. Hey McNets, thanks for joining. So it adds the currency symbol at the front, and then to convert back basically says, if you type a number directly in the text box, then it will convert that string to a decimal and set it to the view model. So now if we take a look at the application itself, you can basically have your 0 here, which is the default value. And then if you type 42 and you click somewhere else in the lost focus, then what happens is that the view model has its value converted back to a decimal, and then the binding somehow comes back through the converter again so that the $sign is added. Now, the interesting thing is that if you change the X bind here to a binding, and let's say if you change that to a binding and say we change that to be the view model directly, so let's say that the data context here is itself, so that the view model here resolves properly. Then if we start that again, we'll see that the behavior of the application is completely different. And we have, of course, the behavior of the bug that happens when you run on the UWP. We have to fix it again. Okay, so if that happens to you, it's a bug that's in the latest preview of Visual Studio. You can go to discussions. There's the shared project issues here, and you can add that line to your project, and it will allow you to get the ground running without having to modify too many things. So let's add this to the project. So we're adding that property group. We reload, and then we should be able to start the project again. Okay, that's much better. So now we can change this. So let's say if I type 45, you click somewhere else, you can see that now changing from X bind to binding now just says that the converter is not coming back. So that means that the property in the view model has been changed, and it has 45, but it's not coming back from the view model back to the view with the converter being called again. And that's a significant change between the two behaviors here. So X bind and bindings are not the same, especially in that case where if you're inside of a binding and then the value changes with X bind, the converter is going to be called back again so that the value from the converter is applied again. So that's pretty nice, because most of the time when you want to do this, you're going to be using things like hooking onto text change of a text box and things like that. So that's something that that's not needed in that case, and it's particularly useful. And I think it works the same way if you don't use a converter. You can also use a bindback and a method binding. So that allows you to go both ways in that case. So that's a pretty useful scenario, and less code for you to write to do this kind of scenario of formatting a text inside of a text box. So there you go. You may also have seen that there's a bug in here. So if you type in with a $, it will not work because the decimal is not going to be parsed properly, and it will return a 0. So in here, if I start the application again, having an X bind instead, you will see that when I type something with a $sign in front, so let's say I do $42, it will go back to 0 because the covered back didn't get to parse the value, sent 0 to the view model. The view model said, oh, it's 0. I'm going to come back with a new 0, and it's converted again to 0 with a $sign. So there you have it. That's the whole idea behind those bindings. So I spent a bit of time trying to figure this one out, and it really is a behavior difference between binding and xbind. Okay, so I see Jose had another question. Could you talk a bit about how Uno platform works when using WPF? You may have to be a bit more specific about this because it's pretty close to the GTK stuff that I explained a bit earlier. So what do you want to know? So let's go to the topic of the day, which is WASM threads. So the .NET team has been working on this for quite a while, and it's all about getting threading available for WebAssembly applications. So something that is of interest. So let's say I go to NuGet.info and I open a large package. So I know of one. Let's go for uno.ui. That one is actually quite big. If you click open, when it's downloading, it's fine. But then you can see here that during the loading of the parsing of the package, nothing happens. And that's a problem because your application's frozen, and it's quite a big deal. So it's normally addressed by adding threading, and that's the kind of things that makes your application faster, and you can do multiple things at once. And especially with the new CPUs that have so many cores running at the same time, it makes it a lot easier to have smooth and fast applications. It's something that also is very important to use when you do async await stuff. Not necessarily that you can do, but let's say if you're doing JSON parsing or anything like that, then it's something that makes your application faster if you're interleaving UI thread stuff and things that need to happen in the background. So there you go. So that's something that will improve the performance of the application. That I think the NuGet Package Explorer is going to be one that's going to be benefiting from that a lot, particularly because we're making things like computing PDB or parsing PDBs and taking a look at signatures and others. So that's a few things that will be very interesting for threading there. And of course, all the clients that or customers that are using Uno that have large application are going to be benefiting from this. So that's going to be fine for them. So the .NET team has been working on it, and a while back, if you took a look at the history of the Mono runtime, some of the engineers at that time, so we're talking about 2 or 3 years ago, I don't remember now, they started working on threading because the threading was available as an experimental feature in browsers, and now it's something that is enabled by default in all browsers, minus a few caveats, and then we're going to discuss those after. But there's a PR that's available in the .NET runtime. It's not, but with Uno, we're able to pick some of those parts and try to get those running without having to wait for the .NET team to get all those bits stable. And I just got this morning a sample running properly. So let's take a look at that sample here. So I had that sample. So this is the Uno's WASM Bootstrapper. It's what packages your application into a website. And what it does is it takes the .NET runtime, or a version of the runtime, the .NET runtime, and packages it with your app, and then lets it run properly. And what we have here is the solution to get that tool, that NuGet package that transforms your app into a website. And it has many samples. And there's one that I had built a few years ago, which manages threads. And I just had to revive that one to get that running. So what we're going to take a look at is, so first we're going to see what the application does. So let's see, I think I had it running. So let's take a look at the code. So what the application does is, it starts a timer, runs a run method, and that run method, what it does is it creates a thread which calls a do work method that adds messages to a list. It's pretty easy, and that list is a static list that's available here. So what we're doing here is running that thread, and then raising a task completion source, which in turn sets a manual reset event that will unblock the timer. So it basically, every tick we're checking if it works properly, and then when we're done, then we're writing that we're done, and then showing everything up. So that's the idea. So if we take a look at the application that ran, we have here a lot of things that were happening, but we have the thread ID showing up. So let me show you the code at the same time here. So we have the thread ID being displayed here. So thread ID, and then we have a starting thread ID 2. So that shows that we really are running a second thread. And that thread is adding stuff in the messages. And when it's done, it sets the TCS here, and then says stop thread. And then once we're done, we have done with 10,000 results that are shown by the main thread, so thread ID 1. So it really shows that we're doing things in the background. So to show that we're actually doing processing in 2 threads and not just interleaving work, we're just going to change that one to show a bit more. So that piece of code here, the tick, so that we are showing that we're really processing the events regularly. So we're checking that for every, so we're changing the due time is 1 millisecond and then period 1 second. Okay, so let's make it run a lot longer. So instead of 10,000, we're going to make it 1 million, for instance. That's going to make for a lot more stuff. So let's run it again. So I see Jose asked for, when choosing WPF or WS 2022, how Uno Plat works in that case. That's a bit more general too. It's all about making the Uno code running there, but I don't know what's why do you ask? What's behind your question? It's going to be easier that way. Okay, so we have the starting thread. So do we have something running here, or are we blocked? So I probably did a wait one here, and that's not the right one. Yeah, I probably stopped the wait one. So let's wait 0 is probably infinite. So let's do a wait one with one millisecond instead. Otherwise it's going to block the main thread, and that's not what we want. So what we want is to have a tick, detect if the event is raised or not, and otherwise we're just going to be pushing things around. So it looks like we're still blocking for some reason, and that's not what I wanted. So let's see what's missing here. So we have the wait one. Maybe we're not getting out of this one. Could be. Or maybe we're writing on the top. Ah, there you go. I thought we were writing on the in the console, so that's why. Okay, so let's write to let's write to the console instead. There you go. So we're going to be writing working. Okay. Because I was thinking, if we have a second thread, it's not writing on the console, maybe we're missing something, but no, it's not the case. So we're actually working. So we can see here that we're really doing stuff in the background. It works as implemented. Exactly, Darren. So we have the main thread, which is spawning events, raising events on tick every second. And it takes about it takes quite a while actually to run in the background and enumerate for 1 million results. So now we do have 1 million results. So it really is doing stuff in the background. So that's very good. So how does that work? So if you haven't seen, working with threads is actually quite interesting. So the way threads are implemented, it's done through workers. So we can see here that there's a worker being implemented, and there's .NET-WASM running inside. So I don't know which one is which. So let's restart it for now. Okay. It looks like there's a lingering something. So let's go and clear the application here. Maybe because it's a worker and it came back again. Okay. Okay, no, we still have it here for some reason. Don't know what that is. But anyways, the idea is that a thread is a worker, and they're actually called threads, specifically. That means that we can't break in. So what do we see? Mono invalid something. I don't know what that is specifically. It looks like it's, I don't know what that is. Maybe it's something that, oh, it looks like it's been, is it? Oh, that's new. That's something that is new. Oh, okay, that's a good question. So it looks like, are they, is it JavaScript or is it, was it converted back to JavaScript? That I don't know. I don't know what that is. We'd have to ask the runtime team, because looks like they're doing something with it, but kind of internal stuff for the runtime to work properly. But anyways, so that means that every time you have a new thread running, you have source of the WASM package. No, there is no source of the source of the WASM package is when you click on the .NET WASM, and you can see here all the methods that are exported. There are not that many, to be honest, because the application is small. But as soon as you get to larger applications, then you get a lot of functions that are available in that specific view. So yeah, that's the idea. So every thread that you create has a .NET worker, a .NET web worker that's spawned to handle the threading, and the communication between the worker and the main thread, if you will, main site, or the main worker, if it is I don't know if it can be called that way, is done through shared buffer. And shared buffer is a feature that allows to, you can write bytes there, and it's a view from one site to the other. So that means that when a worker wants to write to some memory, then it basically shares the memory with the other workers. So it reproduces the memory model, or the memory layout that you have when you're working with .NET in general. So it kind of looks familiar in a way that it works. Now, with the other things that are interesting, that's where we're going to go afterwards, is how do we get from the background thread to the foreground thread? And that's what I don't know, and we're going to have to figure this one out. Maybe there's going to be a way. I thought in the mscripting documentation there's something about this, but the idea is that when you're in the background thread, when you're doing it, let's say you're making a console app, or you're making a WPF app. If you're in a background thread and you want to come back to the foreground thread, you're going to be using a method to do so. So for instance, you're going to be using dispatcher.runAsync if you're on WPF, or if you're on UWP, or if you're in WPF, it's going to be another method. I don't remember which one that is, but you're going to have to post a message to the event loop so that the UI framework is able to handle that and allow it to process what's needed in the main thread. Now the problem is, if you're managing if you're making that main thread, you're gonna have to have something that wakes you up and says, the background thread has forwarded something to me as a main thread, so I need to wake up and then process what's coming from the other thread. Generally, it's a delegate or something like this, and then execute that delegate on the main thread. But the thing is that on WebAssembly, we don't have that luxury because we're not managing the main thread. The browser does it for us. We're being invoked regularly, or so for instance, if you move the mouse, the browser calls you and says, here's what happens with the event. But there's no way to say, hey, background, I'm a background thread. I want the main thread to wake up, and or so I thought. So we're gonna try to figure how we can have the background thread wake up the other one, because the problem here, and you can see that the main thread is actively waiting for the background thread to set the auto reset event. But if your application does nothing, I don't want to have Uno just loop through things to and so particularly if there's nothing to do, to loop through nothing to do, and that would be a waste of battery and waste of resources. So I'm gonna have to figure that specific bit out to understand how we can navigate between the two. So I think if we go to the Emscripten repository, there's some documentation about threading. So there's a few things. There's pthread support. There's WASM worker. Let's see if there's something else with threading here. So I don't see any. So let's go take a look at the threading. So so there's a way to sort of compiling that. All that is done automatically for us. We don't need to do anything. There's a default thread pool size so that you can enable concurrency by default, but there's kind of a default number of threads that are spawned automatically. Proxying. Okay, blocking the main thread. So that's not good. So that's the thing that you don't want to do. And if we were just blocking the main thread, that means that the browser wouldn't do anything, and you would get the message that we had there, which is blocking the main thread is very dangerous. So don't do it. So, and actually it goes to that specific one. You can ask it to allow blocking for the main thread, but that's not what we want. So there's probably a way to go back to the main thread. So there is a set main loop, return to the main event main loop. So if you create, so Emscripten set main loop, so that's not what I want. Is there something else that we can do? So I thought there was some kind of a trigger. So if we take a look at the way the managing works between the two, Emscripten is creating a what is called a message listener. So if we go to the site itself and we take a look at the source for .NET Worker here, we'll see that there's a on message here, and that on message says, the worker is woken up, and then when you're loading the worker and the thread, then here's the WASM module that you need to use. Here's the memory. Here's is it a p thread? What to load and what to load. The clock drifting, which is interesting. So there's a lot of things that need to happen between threads. But the idea is that we need to be able to say, we need to be able to use that communication channel to be able to go from the background thread to the foreground thread, but as a message, but not as a blocking primitive like a mutex or a mod editor or something like that. So we can see here that there are a few things like this. Like there's a set immediate. I don't know what that is. There's a proxy in queue. There's a process thread queue, which is not what we want here. The thing is that most of the time when we're creating a thread, we're not going to relinquish the control to the worker itself. We're generally going to block the worker using a monitor or an event or something like that, or an infinite loop or something. So we're going to have to take a look at where that one is going. So let's see if we can find an on message somewhere, but inside of the main.net.js. There's probably something that looks like this. So is there an on message? Okay, so we got worker here. And we're going to try to find if there are messages that can be used from one to the other. So we got the few message here. So the worker, we got the command. So process queued main thread work. Process main thread queued calls. That is interesting. Okay, so let's go take a look at what that one does. Maybe there's a way to, there's an API that does that. No, there isn't here. So maybe you can go to, so we can't search the code here. Maybe we could be, so not logging in here. So I'm going to be cloning Inscripten. Let's clone Inscripten, so it's going to be easier. And we're going to open Inscripten directly in VS Code, so we can search for everything here. Okay, so so we want Inscripten, and we're going to search for that method that we found, which was process main queue thread work something. Let's see how we can call this one. My assumption would be that there's going to be a, where am I? Inscripten. Why don't I see this one? Did I clone the right one? That's interesting. Okay, maybe I'm not looking at the right code. So is it this one maybe? Okay, there you go. Okay, so we got threading here. And what do we do in there? So we get yield, we get pthread. Maybe there's a way to get to that method. Run in main runtime thread JS. Looks like it's an interesting method here. Inscripten sync run in main thread. That's not what I want. Well, not synchronous that much. But that could be interesting still. Because the thing is that we cannot override this worker on message because we don't know which one it will be. So we need to be able to invoke from the background to the foreground. And yeah. Hey, Pedro. No, I can't. That's the thing. It only works if I'm logged in. So I can't be logged in there in that specific environment. It's only available when you're logged in. So would it be that one? Some script and async run in main thread. So maybe it is something that is manually invoked, but it's probably not that useful. So there's a function pointer here. Run in main thread. So maybe we can trick it somehow with something else. Let's see. So if we go back to the main here, we have a process main queue thread. We have print, we have alert, we have an abort, but we don't have anything that allows us to go back to the main thread. We got message, we got detach, but we don't have anything else with processing that allows us to go back easily to the main thread. All of this looks internal, and that's gonna be a problem. Finished loading. That would be the right one. But I don't see any invocation that we can do with this particular method. There's a dispatch to thread, but that's probably not what we want. That's all very too internal to be managed directly. And there's no invocation at all in any piece of code that's there. Oh, there are some. Okay. Unscript and run. Okay, so the forward underscore is a problem, but maybe we can use it for something else. It looks like it's used in WebGL to do some work on the foreground. Is there another test that we can use? Okay, so maybe we can do something like this, because it doesn't look to be too complex. Still need to have this, which is a pointer, but okay, we can try. Okay, so let's see. What we need is basically being able to invoke a method. Doesn't need to have any parameters because we can get the parameters anywhere else, because we can write to a queue, we can write to anything else. So we need to be able to invoke that method with two parameters, that one and that one. Okay, so let's write this one. Let's try this. So to be able to do this kind of invocation, we're going to be making a static class. And it's going to be, let's call it mscripten interop. And we're going to make a static extern void. So we need this. We need this value. I'm assuming that it's going to be an integer. Threading em signature. Where's that one coming from? Unsigned int. Okay, so we have an unsigned int here. So let's do int signature, and then here we need a delegate. Delegate, which is going to be just a simple action. Okay. So that looks good. And then we're going to have to do DLL import. So there's a special DLL import that needs to be called. Let's go take a look at the documentation for the Bootstrapper. Yeah, let's go for the documentation of the Bootstrapper. Oh no, wasn't. I think I had it here. No, I don't have it here. Bootstrap. So to take a look at this documentation, we have to go to the runtime execution modes. And then there's a way to have external, no, it's not that one. It's, did I lose it? Okay. Embedded mode, native linker, module linking. Okay, module linking. So for the module linking, we need to be using a specific import, and it's called native. So let's call it that way. And the signature is the right one. That should be good enough. Now, the thing is that we may need to be able to invoke this using using additional parameters, but let's see if we can invoke it with, let's see if we can do this that way. So we're going to be invoking one method, so it's going to be a static method. So let's call it my method. We're going to be writing, let's call my callback. And okay, so that's it. And what we need to do is now call that method from the interrupt from let's say the background thread. So at the beginning of the background thread, we're going to be calling it once. We don't know the value of the signature, so it was emfunc v. Aha. Okay, so which one is it? So it's 0. Okay, that's going to be an easy one. So we're going to be saying 0 and a target of my callback here. So what that should be doing is invoke the my callback method from the background thread to the foreground thread using the callback here, I would guess. So let's see if that works. So we may have to modify a little bit of the runtime because I haven't tried that yet, being able to invoke that kind of custom code. Okay, so one of the things that need to be done when developing the Bootstrapper is because it uses MS build tasks, and we need to be making sure that we terminate all the MS builds as well as the IS Express that are running. Going to be using the embedded one. So let's rebuild all this and see if we can get something to run. So we're building the Bootstrapper and then we're building the threads. So now it's going to be using Emscripten directly when building and not just the other ones, but I don't know if it worked. Doesn't look like it did anything. Let's try it anyways. No, it won't work that way. So we have to add the support for the native exports. So let's do this one. You're going to be adding a new item group, which says that native is available for calling from C#. Okay, so I need to kill that again. I wish that MS build was not locking any of the DLLs, but it does. So we need to kill MS build every time we restart the builds. That's not fun, but that's how it is. Okay, so now it's using Emscripten. We'll see if we need to change a few things to get that running. So it's still using Python for some reason. I'm not sure exactly what it is doing at this point. Okay, probably installing Emscripten because I don't have it on that machine. Okay, so we have Emscripten installed. First run with Emscripten is a bit long, but afterwards it does fine. So that should be enough. It may be that we're gonna have to add a few additional parameters to get threading to work properly. Okay, so it looks like still running. So it's running AMCC. So I don't recall if I added the parameters to get the runtime to include threads, but we'll see. Let's see. So we have the packager here, which invokes Emscripten. And let's see if I had thread options that were available somewhere. It's some here. Got the worker. Okay, so it failed, which is we likely expected. So we're going to find what's missing. I don't have the logs here, so let's add this. It's a package that allows to see the logs from the build without having to wait too much. So let's install this. It's a very useful package from the Microsoft the Project System tool team, and it gives you bin logs from your build, so you can diagnose very finely what's happening with your build. So I thought we would have been able to take a look at the other topic, but it looks like the thread is giving surprises. So let's continue with this one. So the update to install the package. There you go. So let's go back to the Bootstrapper and let's build again to see if we can see what happened. So the tooling that I just installed gives us an additional menu for which we can record the logs when the build is happening. So it's in the view and view window, other windows, and you have build logging here that appears. So when you have the build logging available, you can just hit the record button or play, or I don't know which one that is. And then when you build, just making sure that don't have any MS build running there. When you build, then you have entries that are happening for each individual project being built, and then you can take a look at those builds individually. So when it fails, it tells you exactly what happened. And Emscripten can give you some deep hints into what's not working, but you have to take a close look. So it's not always easy. That's why we prefer to log to that bin logs. It's easier to manage. Okay, so still running, and the build failed. So let's go take a look at our bin log. So basically right click on it, open in external logs, and then we have here not enough logs. So let's go change this. So when you install the tooling, you also have to go to build and run here and change the project build log verbose file verbosity. So you have to put it to diagnostics. And then when you rebuild, that you're going to be having a lot more information to work with. Okay, so missing some output. Let's start again. So now we are at the threads project. And we're probably going to be getting the same error that we had before. And we're going to be able to troubleshoot it to see what we need. There. So what's the error? It says scripting async run in main thread. So okay, so all the threading stuff, it's not defined. And it's probably because we need to have a few additional properties from the .NET runtime that we don't have currently. So let's go find them in the .NET runtime. You can type. So those files are in mono and WASM, and we have the WASM proj here. So we search for mono threads. We're going to find a lot of specific features that are added for the runtime to be enabled for threading. And we don't have USB thread, we don't have no mem thread growth, and we don't have thread pool size. So we're going to have to add those to the linker parameters, as well as CMACD disable. I don't know what those are. Looks like some runtime things. So we're probably going to be skipping those for now. So let's add those. So if we go to the Bootstrapper, if you take a look in the packager, we have a few additional properties that we can enable if the threading is enabled. So if we search for threads, we have a bit of .NET Worker added here. But we're going to be having to add that later on. So let's go find, so that's when we created some Ninja files. I think we're adding a few fields here. So we have the link flags for the EMCC linker. We will also have the MCC flag. So we're going to be adding them to both targets. Enabled threads. So if we do have enabled thread, we're going to have to add a few linker flags and a few compilation flags. So the first one, we're gonna add both of them on both. Well, all three of them on both. So we get use pthread to 1, and we have a warning that's added. So we're removing the pthread warning for memory growth, which is fine for now. So let's add. So again, the thread pool size. So that's the default number of threads that are created when the application is starting up. And that's it. Okay, so let's see if that's enough. So we're rebuilding everything. So the packager is actually an older version of everything that was done in the mono runtime when it was in the mono/mono repository. And now the .NET team has moved to more MS Build centric packaging. We're not there yet with Uno for a variety of reasons. But the main one being that there are missing features in .NET Runtime that we're not having in Uno, specifically, for instance, the fact that we're changing a few things in the output, and that the packaging that the .NET Runtime is doing at this point doesn't do that. So we're probably going to be making some PRs in the .NET Runtime to fix this, or to add that feature because it's missing for us. There, along the way, we added things like support for PWA and things like that Blazor is doing on his side, and that the .NET Runtime is not doing. So we need to re-implement those. But that's the kind of things that we don't want to be managing in the long run. We want the .NET Runtime to do all of it, and we just concentrate on focus specifically on Uno and not necessarily too much down low at the WebAssembly level. So that's the idea. Okay, so it still failed. Let's go see what's missing again. Okay, so we have a lot less issues now. So we have an undefined symbol, and the undefined symbol is mscripten sync run in main runtime thread. So my assumption is that that needs to be exported. So we're going to have to change the exported functions list. So let's see, exported functions, or maybe we need to have the underscore. That could be. So let's see if we add the underscore, maybe that's going to help. Because the symbol is already defined in mscripten, but maybe it's because the name is different. So let's change this to see if it helps. So you'll see that because we're building with mscripten, the build time is going up significantly. We're talking about 30 seconds or so, just because we are adding the import for some native code. I know that the .NET team has been working on getting this to be easier to work with. So it failed because we didn't kill MS Build. To have mscripten work a lot less when we're building the application, but that's not what we have at this point. So we need to wait a little bit when we're building those larger applications, or when we're actually not building larger applications, because this one is very small, but when we're building for when we're actually using interop in this case, so using external methods that are native, because this one is specifically implemented in the mscripten provided APIs, so we can't call it outside. We're getting farther. Okay, so this one is interesting. So that's a lot of code. Joer, when you press the dot, it's actually something that you can use. So if you go to hub.dev, if you log in here, well, actually, not log in here. Let's see. GitHub.dev. There you go. Press a key on any repo. So take a look at this one. It's going to help there. It's a very good feature. I use it a lot. It's just I'm not logged in here, so I can't use it. Okay, so what we're seeing here is the fact that we're invoking a step after the generation of the WebAssembly module, and we're not enabling one specific thing with the validation. So WASM opt, it's something that is called here, and let's see, I can see it here. I don't have the WASM opt here, so let's find this one. So let's go in the packager, search for WASM opt, and when we're calling WASM opt, it's something that allows us to do stripping the dwarf information. So all the debugging information, it allows us to remove that, so that if you're not using them, it's not needed, and it makes the package a bit smaller. Thing is that that particular option needs to have additional features added. So we have exception handling that's available, but not threading. So we're going to be adding that. That being said, I don't know which parameter that is. So we may need to go and figure where we can find that property. And if we don't find it, we may have to run that specific command by hand to figure out what we need to do with it. So do I have... I don't have mscript in here. So I do have it in the... on Windows. So that would be .uno msdk. So it's a 317. And then afterwards, I don't know. I think it's upstream. No. What's in there? There's been WASM opt. There WASM opt in there. There it is. WASM opt. So okay, so it just does nothing because it probably takes the console as input. Oh, there you go. That's a lot of parameters. So in there, what we need is some additional flags that will allow us to do threads. Okay, so we have enabled threads. What I don't know if we need, we probably need the other ones because it failed with enabled bulk memory. So we're going to be adding all of them at once. Okay, so let's add threads. Let's add bulk memory as well. There you go. Oh, wrong window. So let's see. So there's this is interesting because the WASM opt is kind of I think it's an optimizer for WebAssembly modules. So it's something that goes at the end of the whole assembly pass, or WebAssembly generation pass. It's one of the operations in the pipeline of generation that takes quite a bit of time, and it has a lot of options, as you can see. I've been scrolling for a while. It even has fuzzing, which is interesting. Okay, so it failed again. What do we have next? So it still fails, but... so let's see if we have another option to add. My guess would be that we do have to add another one. All used features should be allowed on. Okay. So maybe there's a catch-all to say enable everything. Let's see. Ah, there you go. All features. Okay. Let's enable everything. Let's see what that does, if it helps for everything. So do we have more to do? Otherwise, if it doesn't work, we're going to be removing the strip command, and that'll do. Just wanted to keep this to make sure that we're not missing anything, but you know, if it's too problematic, I wanted it to be educational to show you what that means, you know, the steps of the generation for WebAssembly. But you know, if it still doesn't work, we're going to skip it, because the point is we want to be able to call back to the main thread, not having to dig into the rabbit hole of everything else. Oh, would you look at that? So all features enabled, that works. Okay, so let's see what do we have. Okay, it looks frozen for some reason. And if it's frozen, that's not a good thing. Okay, so let's go to localhost for now. Exit page. What does exit page do? Ah, that's better. Okay, so let's open the debugger, and we're going to see what happens there. So in the console, we don't have much. P thread completed its entry point with an unwind, keeping the worker alive for an asynchronous operation. Okay, that's not particularly interesting. Okay, let's go and write a few more things here. So we should be been able to do here. So the starting thread didn't say anything. So maybe we need to be on the console first. Or maybe we didn't initialize everything the right way. Could be that as well. Because it looks like the workers have been created, but nothing started up yet. So it looks like we didn't create everything, and it may be because, what could that be? Maybe we missed something from the .NET runtime. So we have the thread pool size here. What do we have next? We have no mem growth here. We have disabled threads. I don't know what that one does. So that one is specific to the .NET runtime, so that's probably not what we need here. So we have all the flags. So let's see, is it because we're calling something the wrong way? That could be. So if we remove this, is it working? Otherwise, let's go and clone mono as well with the .NET runtime. Maybe we're going to be finding something interesting. There we go. So the .NET runtime is a bit bigger to clone. But still not too bad. Okay, so the bill is finished, but I don't think the application is updating, so we're gonna have to stop this one. How can we do this? We can't pause anything. That's the thing, is that when you break something using threading, then nothing works afterwards. So let's see, we're in the console. We start, do we have anything here? Oh, so the application's not starting up. Oh. Of course, I forgot to kill MS Bill, like every time. The thing is that we can't automate that inside Visual Studio, because if you're in an MS Build task and if you kill everything, then you're going to kill yourself, which is not particularly interesting. So let's go find if we have additional WASM threads parameters that we missed. That could be. So in the .NET runtime here, so we search for mono threads. Let's see where we have additional flags that may have been set. So we have the -p thread that's here. We have threads provided to the compiler. It's the AOT compiler that we're not using here. What do we have there? Tracing, it's not useful. that's options that we don't use. Okay, so we don't have it here either. So we libicu. Ah, that's interesting. So libicu has a different set of files, but I don't think we need it here because they're copied at the right location automatically. So with the thread pool size, we get the USB thread that's set properly. That's very interesting. Okay, so we got that dot. Oh, it was. Did it go to the right place? The wrong place. It looked like it. That's why. So we still had the WebAssembly browser running at the same time. Okay, so it's still working. Okay, so it's what we did that broke everything, because it's still working. It's still working, and we did the build. I'm confused. So maybe it's calling this that broke everything, which is a problem. But for the last build log, just want to make sure that we actually ran Emscripten. Otherwise, it would not have been the right build. So 39 seconds. Okay, so that's the right build. Otherwise, it would have been a lot faster. We have pinvoke table. Okay, so that's the good build, and we're using the linker settings, and we're running everything. So it says function signature mismatch. It's not the right one. Oh, okay. So that's probably why it's breaking up, because we're not invoking method with the right signatures. So the signature is supposed to be in 32, and we're invoking it with 3. That's interesting. Not sure why we're getting this with 3, but otherwise we're not using the right one. So let's go back to threading for Emscripten. Ah, I see. It's there's the variadic parameters at the end. Okay, so that's why. Okay, so we're going to be adding that parameter as well. That's why everything was messed up. Okay, so we're going to be adding an end pointer or something like this. End pointer unused, and we're going to set it to end pointer 0. So you can see it's the type of signature that takes parameters at the end, because we're invoking with multiple parameters because of the signature that's available here. But the thing is that we're not providing those. It doesn't matter that much because we're at the top level. Mike is saying, do we need the SIMD flag? So no, we don't need that one. It's actually another feature that the .NET Runtime team is working on that will be enhancing the performance. We're using SIMD intrinsics. So if there are specifics that use SIMD intrinsics, like I don't know, video processing or things like that, those will be enhanced automatically by using the SIMD features that are provided by Emscripten. But it's very, very, very new. I think it was merged a few days ago, so I'm not sure if it's going to work yet, and I'm not sure if it works everywhere as well. Well, let's go take a look, because I'm not sure. WebAssembly.org, and you got the future features with the map of everything. And we got a winner. Safari doesn't have SIMD. So if Safari doesn't have SIMD, that makes it a non-starter, forgetting that available for everything else. I think there's a few others like Relax SIMD. Firefox has implemented it. But anyway, so yeah, it's not available yet, so I don't think we're going to be enabling it anytime soon in Uno as a result. Okay, so the build worked properly, and it looks like it restarted the app. Okay, so we got something a bit different this time. It says fatal handle exception, entry point not found, mscripten sync run in main runtime thread underscore. So this is something that not at runtime is providing. So it says that that specific method is not found when building the application. But that's the good thing is that we now have something that makes sense because we have the starting thread that's showing up, which was not the case before. So we're progressing. Maybe we don't have the right signature because we were saying void here. So maybe we need something different. So is it defined as void here? So we have mscript and sync run async. So we have async. We have an async version of it. Maybe we should be using that one. Let's go use that one instead. Because that one doesn't return anything. So it's a void method. And it's probably why the other one was failing, because this one's supposed to be returning an integer. And the signature that we defined in the program here didn't have an integer as the return value. So could be because of that. So let's see. Is it going to be better this time? Now with regards to SIMD, I wish it were everywhere, because I think about 20 years ago, I was doing some some algorithms like making fire and stuff like that. That was nice. Kind of manipulating a frame buffer and doing some fire using SIMD, and I think it was 20 times faster than doing it using standard looping and things like that. So that was nice. Now we're talking about the original SIMD, so the MMX extensions that were there originally. So that dates back. I don't know if some of you have done some MMX assembler, but that was fun. You have to have your head wrapped around it to get to something that makes sense, because it's pretty different. Okay, so we have the build that worked. So let's see. Do we have something new? No, I don't think it built properly. Let's try it again. So with regards to the other features that we're looking for, some of the interesting ones are memory 64. That one is interesting because you can allocate a lot of memory. Multiple memories is, yeah, way farther than what we need. I think that they're going to be using this to add support for what they're called WASM processes, if I remember correctly. Module linking. That one would be interesting. And then we have exception handling. That one is actually quite interesting. And it's one that's already available as part of the latest dev builds of the WASM Bootstrapper for Uno. And in some very small corner cases, well, if you have a method that has a try catch and then you invoke that method, invoking that method, if it doesn't do anything, is about 1.75 times faster than using the previous mechanisms for exception handling. And that previous mechanism was using JavaScript. The new one is using the WASM exception handling, and that one goes fast. So that's very cool. It's not twice as fast, but it's a lot better. And it avoids it reduces the number of frames when you're executing something in the browser. So that's nice. Okay, so WASM thread built, and it looks like it doesn't refresh. Yeah, it's probably because the app is frozen. Okay, so let's go create another one. Let's open the debugger before. Ah, right. The application is not started. I have to start the application for the application to run properly. Okay, so, oh, we have a winner. Okay, so that's a lot better now. So it says platform not supported exception, no native managed transition for Uno platform. My callback is missing unmanaged colors only. Okay, so let's add this to our callback here. So this is actually quite interesting. We're going to go take a look quickly at what that does. And it's creating an entry in a generated file. So if we go to the bin folder here, we go to the work AOT, there's going to be a method. So we got a p invoke, and there's a p invoke table. And in the p invoke table, we're going to find a lot of things, including our our mscripton run in main async thread. And there's a table the other way around, which allows to call the method back from the other one. So if we search for our my callback here, it's not probably going to be in that one. I think it's in the other one. I don't remember where that one is, but it's generated somewhere. I'm missing it. There's another driver gen. That's another one. No. Core bindings driver. I thought it was in that method. No, it's in another one. Oh, it's a pointer that's generated underneath. But anyways, there's a table that's available that does that, and that does that binding back to the existing method. Okay, so it says, oh, that's why, because it was not compiled. So my program callback is attributed with unmanaged caller to obtain a function pointer to that method. It's not exactly what I wanted, but let's see. So do I need to do some unsafe code maybe? I don't know about this one. So we have a new method here. Let's flag it unsafe. We allow unsafe code in the project. And then we should be taking the address of this. I don't know if we can do this that way. Let's see. I'm going to take a look at the documentation because I don't remember how that works. Ah, right. Okay, so we need to be using this. Okay, so we need to use a delegate that looks like this. I don't know if we can use a delegate without parameters. Okay, so let's try it out. I don't know. I don't recall how that works. It's not something that I use often, so it looks a bit weird. Okay, so it's unmanaged, C declare. Function pointers is not available there, so we have to upgrade to C#9. We could probably just move to .NET 6. It's going to be easier. Okay. And I don't know. I don't understand the signature of this one. Okay, so let's go take a look at how to do some delegates, unmanaged delegates, because I don't know how that works. Is there a link to the method here? Address of operator. I don't know if it's the one that we want. No, it's not going to be that one. So is there, let's search for delegate unmanaged in C#, unmanaged types, function pointers. There you go. Okay, so we have int void. So maybe there's a way to just say void instead. Does that work? Still says that we can't use it. We're in .NET 6, so that should be working. Function pointers not available in C#8. So, okay, so we're probably going to, it's likely that we're forcing the language version to be below. Okay, there you go. That works. Okay, so that is good. Program callback is not compatible with C declaration convention calling convention. So we need this one as well. So manage colors only. So we need to add that in front. So it's actually callable from C is it which? Okay, so that's good. So that's a lot of low-level stuff. I don't know if I've lost you, but we're gonna get there. So what we're trying, so just to be recapping everything, what we're trying to do is have the background thread call back to the main thread using messaging from mscripten, because we can't do it using standard blocking techniques. So we need to have a message that comes up. We need to have a method invoked in the main thread using the message loop from the browser. So that's what we're trying to do here. So to do this, we have to have be able to invoke a method from the background thread, and to do this we need to go through some internal methods that are coming from mscripten. So that's what we're trying to do at this point. And to be able to do this, we need to be able to call back that method from the background, and to be able to do that, we need to use the new feature, which are native, or what they call it, what was the calling for that? It's they're called function pointers. There you go. So it's actual function pointers to be invoking something from the C code, because it's not the .NET runtime that's going to be invoking that method below. It's going to be mscripten. And then when that is invoked, the main thread is supposed to be receiving the message using the myCallback method here, and it's supposed to be showing up myCallback, at least. So we'll see if that's if that works. Okay, so let's see. We have that. I don't think the application is running. So if we refresh, it's still blocked. So let's do it from another one. Okay, so this time we have, it says mscripten async run-in made thread is not found. That is interesting. So we're back to the original one, which said it wasn't working properly. So the entry point is not found. Why is it not found? Okay, so when it says this, so when the runtime says this, that means that it's trying to find, in the pinvoke table, it's trying to find the method that we're trying to get to. So it's supposed to be finding that specific method, but for some reason it's not finding it. So maybe because we're not rebuilding properly. Let's see. So let's rebuild completely to make sure that we're not missing anything. So Jose says, we like unsafe code samples. Well, that's the thing. It's not completely unsafe. So, and that's pretty bad, because they said that it's unsafe because we're manipulating pointers and things like that. But it's actually safe because you cannot you're not calling too many weird, you're not doing unsafe stuff. You're calling a method, and in the C# side, it's safe because you're not going to be invoking some weird things. Now, if you're passing a pointer to a method that's supposed to be having no parameters and returning void, but you're doing something else instead with it, then you're going to be unsafe. So probably it's because of that they did it. They probably did it that way as a result. Okay, so let's go back to the entry point. So what do we have now? Okay, still no, I haven't started the app, obviously. Okay, still no point, no entry point found. So that's very interesting. Because the method has been, the compilation worked properly, so that is good. But it feels like this one is it's not using the right entry point or something, because the method's supposed to be there. So otherwise it means that the signature is not the right one, maybe. It started happening when we added this. Maybe in the pinvoke table we have something different. So if you take a look at this specific method, it's 3 integers. That's very curious. Let's remove the underscore for now. Let's see if we rebuild with the underscore, without the underscore, and if it does something different. Because this method is supposed to be provided, but I don't know if the fact that the symbol is with an underscore in mscripten, because we can see here that they're rewriting that specific method, specific function, into this specific function with the underscore at the end. And my guess is that it should fail the build because the symbol does not exist. So maybe we're missing something. It still builds. That's very odd. Or maybe I'm not looking at the right location. Could be that as well. So we're looking at that net 5, so maybe that's not the right one. So we have the pinvoke table here. And do we have our... it's not there. That's why it's not working. Okay, so we're missing something here. So it says mscript and interop. So that one is supposed to be here. It's not generated. So are we missing something here? So we have the DLL import. We have the pinvoke native library here. Let's call it something else. Let's call it mscripten for now. Maybe it's a different problem. So that's why it's not working. It's because the generator did not find the method here. So I don't know, maybe it was excluded somehow because it's the end pointer or something. Or maybe it's because of the delegate. So let's see. So in the work AOT, we're going to be generating the new file for the signature that maps to this method specifically. So we have the pinvoke table that's going to be coming up. There it is, the pinvoke table. And we still don't have the mscript then imports. Okay, so so that means the import is being skipped for some reason. Maybe. So why is it skipped? So let's create another one next to it that uses the original action to just make sure that we're doing the right thing. So let's call it with the underscore here, and let's use a uint instead, just in case there's a problem with the generation. Okay, so this one fails because we're not giving it the right things. Okay, so now it built. So let's wait again. So we should be having both signatures, but if we have only one, maybe there's something that the generator is skipping for some reason. So it could be because of this, because of the type of pointer, because of could be many things. So the code that manages this is inside of the Bootstrapper here. So we're going to be able to take a look at this. Okay, so we got the table again. Okay, so we can see that mscript and async run in main with the underscore is available. So that works. But I would not be surprised that the generator itself doesn't understand that signature. So let's do it differently. Instead of using the manage handler here, we're going to make a variable out of it. And we're going to be using a uint callback. Let's call it callback here. And let's make a handler. Make a variable out of it. Are we able to do it that way? Can I cast it? Yes, I can. Okay. So it's not particularly nice, and uint is a problem. So let's go, because that thing is going to be breaking when we're going to be doing x64. Uint is not big enough for a pointer. So, and it's probably the same for this one. So let's actually use pointers, the actual pointers, and not anything else. Because in pointer is mapped to the underlying register size. So if we're 64 bits, then in pointer is going to be 64 bits and not like an integer, which is going to be only 32 bits every time, even if you're running on a 64-bit machine. Okay, so now we can go and take a look again at the pointer table, and then we have both. Okay. So that really was the problem. And that's for sure, Darren. So we have both. That's good. So now we should be able to run it again. Well, it's starting everything again, but so we can close this one. And this one as well. Here we go. So what that means is that if that works, and it looks like it's going to be, fingers crossed, that means that we're going to be able to run everything to make the implementation of dispatcher or core dispatcher dot run async. That's the idea of the use we got behind this. So we can see here it doesn't work. There's a good reason for it. It's probably because that specific symbol does not exist. So if we take a look at the output here, it's going to say that mscripton main thread, the runtime thread, does not exist, and there's a good reason for it. It's because that one is defined in here, but the actual method is with an underscore at the end. So we're going to drop this one. Actually, let's do it for this one here with the underscore at the end and remove the other one. And let's try again. So that's very fresh, you know. There's not even a build in the .NET runtime that does this, because the .NET runtime from the .NET runtime repo doesn't have threading enabled. So it's before the bleeding edge. No, in front of the bleeding edge. Yeah, in front of the bleeding edge. That's what it is. Okay, it built. So that means all the symbols were found. So we should be able to run the application and get something interesting. You can see working here. My callback has been called. How amazing is this? Ah, that's very good. Okay, so we got our solution to be able to do some cross messaging from the background thread to the foreground thread by using one single method. So we still have a few issues here. P thread completed its main entry point with an unwind, keeping the worker alive. So we may be still having a few things that are not working properly with the invocation of my callback, but who knows? Okay, so what we could do is try to invoke that method more times so that invoke main thread. We're just going to be updating. We're going to be calling it in the do work. So let's say if I every 10,000, every 1,000, we're going to be invoking the main thread. See if we can do it multiple times. And if we don't have any other weird stuff that's not happening the right way. So let's try this. So that means that we're going to have a good solution, because previously that feature of invoking the main thread, and when we originally were working with threading in .NET in mono/mono, so 2 years ago, that feature of calling back to the main thread was not existing. So that meant that the support for threading in Uno and calling back the main thread was very poor, because there was no, we had to do some active scheduling to check the. That works. That works pretty well. So we have my callback that's invoked way too many times, but that's fine. Okay, so let's do it a bit less. 10,000. Yeah, that one's gonna be good. So we had to do an active loop. So let's say we had to have a timer on the main thread that was validating that there was something to do from the background thread. That's not good, because when you're posting something, it has to happen immediately, not sometime after or some timer. And the problem with the timer is that if you have a timer that's always there to keep track of what's happening in the background, then you're using battery for nothing pretty much, and you're keeping the process alive and doing things. So it has a significant impact into what the application is doing. Okay, so we have my callback being called every so often, and to be able to invoke the foreground thread. Wow, that's nice. So we made quite a few things there. We were able to invoke from the background thread the foreground thread using standard messaging techniques that comes from mscripton. We've seen that we can call we can call some code, some method from Emscripten from the .NET side to the background. So from the .NET side to the other side. So the native side or WebAssembly side, so that we can invoke a method that posts message back to the main thread. And we can have Emscripten call our method automatically with using the manage colors stuff here. So that's pretty cool. That's very, very cool. It's likely that we're going to have to make a custom version of the runtime, because it's not nice to have something that does what you're seeing here and spend that much time invoking some methods from .NET. So we're going to have to do a few things around this, but the base is here, and that's very good. So I hope you learned a bunch. I did, as always. And that was very good. So I know that I can invoke some interesting Emscripten features from the background thread, and we can digest that for next week. So happy coding, and until next time, bye for now.